So I've been doing these streams for a year or two now, and I've been working on a lot of different projects on these streams. And today, I finally reached a point where I'm trying to start merging some of these things together. So look at the screen here. I've got 3 different projects that are up. This one I've streamed quite a bit lately. This one I streamed quite a bit a year ago or so. And this I haven't really published a lot about. I went kind of dark for a while. This is kind of what I was working on. This is in a browser. Um, this is a Smalltalk application that is for drawing and animation. Yeah, I've got like a little hello world meant to be like an intro to a section of a video. So you have this little thing come down and just as like a chapter heading for your video or title or whatever. And the idea was that I would be talking to, what just happened here is I switched over to the browser and it made a WebSocket connection to this thing. Rectangle turned yellow, indicating that there's now a connection here. And I've told it to, when the playhead moves here, to send a message down the WebSocket telling it to update. So if I drag this back and forth, see that it's now sending a message to the browser basically on every few milliseconds, telling it what SVG to display. Okay, fine. That was kind of a silly way to get the output of this thing into the browser as quickly as possible. Inside the browser, I've got some experiments I've done with SVG animation. So like this is a slider that is controlling an SVG or it's a JavaScript animation. There's a web API for animations where you set up the keyframes that you want. And so here's a little SVG scene, I guess. And then as I move this back and forth, this little guy moves up and down. And that's all done with just keyframes in the, it's a keyframe animation API is something that the browser provides for you. And this just says, okay, here's the point at which the point on the timeline that I want to visualize. So I'm just have a slider hooked up. So basically, I'm doing the same thing that this does. And what I'd like to do eventually, I guess I should back up and say that. The idea for this whole web thing that you're looking at here is that I want to move all these applications into one place on the web. When I set out to start building some of this stuff, a year ago I was employed. I was working on this, and since then I was laid off, and I started switching over to the idea I was going to make a programming course. That's still the plan. But along the way, the programming course is meant to be based on this virtual machine that you see over here. I don't know if you see the virtual machine. This is the memory of the virtual machine. These are some scripts that are in the virtual machine's assembly language, and this is like a REPL, and this is a screen or register. And the idea was that I would use this virtual machine as the content, as the topic of the course, but it would also be something that I could use to actually power applications. And the idea is that I've had for some time now is that I like here these are 3 different tech stacks, right? This over here is a thing called Decker, and it's it can run in a browser, but it's also basically its own little universe. Here we've got some JavaScript and some web components, and it's talking to a little Python server on the back end. Here we've got Glamorous Toolkit, a whole little Smalltalk development environment. And it's like I use all these different tools, and I want to be able to, I guess, not have them be isolated, right? Like it's in some sense, using a lot of different tools is an advantage because you can have the access to all the things that each little environment provides. Like I made this little widget here to let me edit um, scripts. And I just, I kind of threw this together. I made a little contraption. It was so easy to make in Decker, and not so easy to make over here, right? This Glamorous Toolkit is optimized for a different kind of GUI building experience. Like they both have a rather limited number of widgets available to you, and if you want more, you have to build your own. But in my particular case, it was just easier in Decker to make this thing. On the other hand, to make this little thing here. On the other hand, to save this out to a file, quite tricky because Decker is kind of sandbox. It doesn't really. You can say file, save, and you can actually bring up a dialog. I guess from the scripting language here, you can bring up the dialog and save something. But you can't just, by default, you can't just save something. The hard drive, right? Like you're protected sandbox. It always pops up something that asks you to save to this file. Whereas over here, you have complete control of your system. You can create socket connections. You can do all kinds. Here you're basically isolated from the world. And here, this is, I guess by contrast, right? The disadvantage of Glamorous Toolkit is if you want to share something, right? Somebody else wants to run this program. If somebody else wants to run this program, they've got to download the Glamorous Toolkit and run my code inside of that. So I've got to like prepare an executable basically, which is fine. It's a perfectly valid way to do things. But it's like it's hard to make a software as a service business, or based around something where you download and do that, right? I'd much rather have everything on the web. There are advantages to having things on the web because you can share it with other people, you can link to it, you can do that kind of thing. But of course, on the web, you lose all the advantages of rapidly creating these user interface components and drawing stuff on your screen directly. And Glamorous Toolkit, you lose the. I haven't really talked about today what this does, but you've got this massive literate programming environment. You've got just so many tools. This is one of the best development environments I've ever used. And it's not necessarily for Smalltalk, but just the ability to lively, to interact at runtime with objects that are running and be able to change the behavior of things and whatnot, and to be able to explore your code base as you're running. It's just a really nice environment. I would say Glamorous Toolkit and Decker both provide that. Well, Decker provides that for Lil, right, for the Lil language, and then I built this virtual machine inside of Lil. The same virtual machine that you're seeing here actually runs in JavaScript, and one of the questions is like, do I move it over to Smalltalk as well? Like the idea is that it's a virtual machine that runs atop your tech stack, and you can have the exact same code running in different environments. And I would like that, right? I would like to be able to say over here, I'm actually in the process of making an editor. I think I made a demo video of V4 stuff, and this is one of those. So I guess the line editor is what I'm doing. Like you can move this cursor forward and backwards, right? There you go. I'm running this little word BW and it's moving backwards. If I do FW to move forwards, but I can't capture a keystroke and move it forward, right? Because Decker does not have keyboard handling for that. You actually can do the arrow keys, but it's rather tricky to just get like a key event. Like you put a button that has like a global shortcut that is that key, and then even then you can't like distinguish between an uppercase letter and a lowercase letter. All of these are for good reason. It makes perfect sense within Decker, but like I'm missing out on the ability to just read a key, which I can do in Smalltalk over here. So anyway, I've ported called the B4 virtual machine. Bring up the so it's at Tangent Storm B4 on GitHub, and I've got implementations in J, Pascal, Lil, JavaScript, and Godot. And one thing conspicuously absent from that list is Smalltalk, because I have a Smalltalk application. Also Rust, because I also have a Rust application. And those two things probably ought to, I probably ought to have an environment for both of those. What I did have, like maybe a year ago, 9 months ago, something like that, I did let me bring this here. I made something that was kind of a prelude to this, which was I added a scripting layer to this system that is a Forth-like scripting language, very similar to V4, but at a very high level. So V4 is a low-level virtual machine. You're dealing with bytes, and the registers contain numbers, and then you can treat those numbers as pointers or whatever. But everything is just a cell, right? Everything is just a number. Whereas here, this is a high-level language. It doesn't really have a name. I tend to call it like something like empty Forth or something like that. It's something where you just associate strings in the high-level language with operations in the high-level language, and so we can actually do something like this, where I'm just gonna run this whole thing. What it does is it makes an animation where it's building a tree to represent a logical expression. So what you're looking at here, the endpoint is a decision diagram. We're saying we have a binary. This is an animation I'm making. I'm making an animation. I want to illustrate this point for a description of the Rust project I'm doing. The Rust project that I work on does this kind of data structure. Right? This is more. It uses a compressed version of this data. So what we're doing is we're taking. I guess I say. How would I do this? I can't pause this in the middle. That's part of my problem. But I can do. How do you do a comment? So if I do this, then we just get the initial drawing. So here I'm taking this. This is the AND sign. This is the XOR sign. So we're saying 3 input variables x0, x1, x2, and we're going to AND x0 to the XOR of x1 and x2. Okay? And then what we do is we will. I wonder if I can just say. See if I can. I'm not sure how. It's been a while since I worked on this, but I bet I can say. Let's see. Self RPN load, and then just do the x0br. This may or may not work. I don't know. And so this is branch on variable x0, and if this works, it should animate just that one part of it. Oh, stack is empty. So I lost somehow the stack when I did this. So loading somehow is breaking that. That shouldn't happen. You need a way to do that. But if you watch the whole thing and speed this up, basically it's going to take this thing. It's made a copy of it, and then it's going to branch on x0. So it should put an x0 up here, and then it's going to on this side it's going to set x0 to 0 and x0 to 1, and so then based on x0 you have 2 copies of this, and that's called a Shannon decomposition of a binary expression or a Boolean expression. Right, so it's like it's like an if then else statement. And I guess. Oh, sorry. Again. Seems I have screwed this up. Just start over. Maybe it doesn't really matter, but kind of rambling, kind of rabbit hole there. But anyway, run, and then anyway, you see us make 2 copies of it. And so this is something that I want to be able to. I want to take this exact animation, and I want to get it running. Either so this is running it from a script. It's not running from a timeline the way this other animation is. Right? So this is running from a timeline. You can see there's keyframes here. So these are the frames of the animation going left to right. And these are things, there's a thing called the stripe and it has a position. It also has a size. When I scroll back and forth, the size and the position change between these two things. Like you can actually see it's kind of like almost like a square when it gets up to the top, and it gets much taller as it goes down. So that's the size changing. And then of course it's moving up and down, that's the position. And then the length of the text to show string hello world, but as we move it from here to here, it stays the same. As we start moving up from here, you can see that it starts adding text as we visit each frame. So the same string is there the whole time, but it just expands. So that's the timeline animation, and that's what I want to convert from one to the other, right? Like I want to take this kind of animation and turn it into a timeline animation so that I can then go back and make it nice and smooth, and not just, I don't know, I'm still thinking this through, right? Like it could be the case that maybe these different words generate the animation itself, and then maybe they generate the endpoints, the timeline endpoints, keyframes is what I'm trying to say. I don't know. I don't know what I'm doing here. All I know is that I want this thing, I want this little language that I've made to run on the virtual machine that I made, right? And so that means, like from this point of view, I've got an application that is a drawing application, yes, but then I'm not using the drawing capabilities of it other than to draw this graph. So I made an object that is one of these. So I think this is called a Bex node or something like that, and it can display one of any number of symbols. Like it can display the and, the x, or the. I can see what I can do. Yeah, Bex node shape. And if I look at the class for Bex node shape, I can browse it. If I did my job of I didn't really organize it all that much. I'll access it. You can put them in different categories. And so you initialize it. You've got, you can see it is a kind of BR frame, so it's basically like akin to a div or whatever, in like it's a frame for holding a widget. And you tell it what symbol to use, and then based on the symbol, it changes different colors. So I haven't looked at this code in a year, so maybe a symbol. So this is Smalltalk code, and it's saying. So find the settings for that symbol. So based on the symbol, we're going to have well, it looks like this is the Unicode string, or UTF-8 string, and this is a background color. No, this is a foreground color. They're all white. It would be white on this blue color, and then the 0 is actually the radius of the corner. So when you say x0 and when you say I and O, this would be false, so this is O. It has this, what's called uptack. And it has 0 for the border radius. And then if you set it to x0, x1, x2, x3, x4, oh, right. So when they're inputs, these are the same. You can see x0 and BR0 are the same. Up here, except for the radius, and then the difference is when it's a square, that means that's an input. So it's the input variable, and then when it's a circle, border radius of 20, then it looks like it's a circle, and that makes it a function. Based on this input, do one of these two things. And likewise, and or and XOR have have some different colors, but they also have the circular shape, the border radius of 20. So if I tell this thing, well, I can just make a new one. I don't think I can. It says this element already has a parent, so I can't do it. But if I say self new, and I just hit shift, I'm sorry, I'd have to hit that button. That is. See anything on it. If I say self symbol, like symbol, it's like X0, right? Oops, no. The key shortcut. I think it's Control D to do it. Yeah, there we go. So now this is we're looking at the live preview of this thing. It's a live version of this live rendering of this thing. Does it like that? And if I say X, if I say BR0, it should turn into a circle. Say we want the and or whatever. Anyway, so this is just an object that needs to be there in the diagram, right? So we've got this basic thing, and then I've got a way of adding edges and connections between that, and then it draws a graph, right? And that's the graph handling stuff is kind of like built into this framework. So if I want to put this on the web, I need to duplicate that framework, and I tend to use a library called D3 for that. So what I'm picturing now is that, again, I want to replicate this virtual machine into JavaScript, which is already done. So it runs here. In fact, I've got it running right here. You can see I typed in 2.2 and it has that. And if I say add, and now it's got a 4 on the stack, the data stack right here. I've got a 4 up here. If I say duplicate that, now I've got 4. I add that, now it's 8. So on. So that the virtual machine works, and I've got it under test. It's working here. And now the question is, how do I get this? How do I make this happen? Like technically, this for the immediate problem, this doesn't need to be involved at all. Except this is like the best development environment I have for this virtual machine, for code on this virtual. And what I want to do, again, I'm just kind of rambling here. I know I'm trying to talk this out for myself, right? I want to get this animation running here in this window, right? But of course, these are words that I've defined in Smalltalk. They're for an application, and so how do I push these down to this low-level virtual machine? I have a couple thoughts on that. One is, I know how it's going to end up, right? Like the way it ends up is that B4, so B4 is the name of the virtual machine. So B4 has the concept of hardware devices, and the way that tends to work, or one way it can work, is you just add an opcode to B4, and that opcode says like draw something. So in here I think I have a canvas one, right? Like here I've added an op. The ops, right? These are all the little opcodes I have, and like I've added one, like it's extensible, right? So all these, this is a bytecode. All these do something. These are all my native instructions. These are like my instruction set, and these two, all the blue ones. This is general purpose input output. This is start the debugger, and this is halt the machine. But these red ones and these green ones are all like free for you to use for whatever you want. And the idea in these are like public and these are like private. And these are two that come with that I've kind of just made up on my own for this Decker implementation. One is the terminal, which draws text on the screen, which you saw over here somewhere. Not here. And the other is a canvas, which is I'm using it to draw these circles. And so the implementation of this is just let me even bring it up because I'll show you, because this is the code that needs to be there in like JavaScript. That would be under G4 directory lil. I know I'm just rambling here. I'm just trying to get this all loaded into my head. All right, so if I say canvas, so this is the lil programming language, and you can see that they're just little one-liners. So basically, the CV op, the canvas op, something I've added to the bytecode for this implementation. So the green ones are meant to be like user extensible. So I've extended it by adding this op called CV. And what it does, so this is the op right here. If you've attached a canvas, so there's a global variable called CV for canvas. And if you've added a canvas canvas to this, then the module has a canvas. Then we're gonna pop a number off the stack. And this A says, give me the ASCII character corresponding to that thing. And then in this CVI is the canvas interface. If there is a letter defined for that, it's a one character code, then we're going to run it. We're going to run that function. So if M, the method name, is in the canvas interface, then actually extract that method. So get one of these functions here, and then pass it in invoke it with the canvas. So and then so B is draw a box, C is draw a circle, and so on. It's actually an n-gon, right? So that's what Decker provides. To draw a polygon, right? It doesn't have a circle. It has to draw a polygon. Right. So that's it. And then otherwise, complain. Either that we don't recognize that op or that the canvas is. So this is very small. This is the entirety of the code, and all it's doing is providing a wrapper for the Decker canvas object. And what I would need to do is port this to JavaScript and provide a similar implementation for the canvas, for the web canvas, right? The Canvas 2D interface or whatever. Right, so that's just the general idea of drawing on a canvas. And then the thought, so either I could do that with a canvas and just have a standard canvas object in JavaScript, or I make something very similar to that, but it's not just a generic canvas, it's a draw a graph object, right? So it's a graph device rather than just a canvas device. It would be a JavaScript object specifically for drawing diagrams like this, just like again, this is a drawing tool, but I'm not using the drawing tool. This is a drawing tool right here. The fact that I can pick it up and move it around is a drawing tool. The fact that I think if I do this, it'll make it bigger or whatever. It's still a rectangle. But like I'm not using that, right? I'm not using this stuff in the animation. So I don't really need the drawing tool. I don't really necessarily need a canvas unless that's what I want to draw it on. And I'm thinking I take D3 and I wrap this. So in the JavaScript world, I would imagine I create a new graph device that is based on D3, D3, the visualization library, draws my graph using these symbols as SVG, right? So it would just create an SVG canvas. That's what I'm thinking. And then the graph itself would have to know how to do these things. So it might just be a graph, or it might be so for example, what this is doing here, if we walk through this code, what we're doing is we're saying, so we're the lines that start with a colon are definitions. So this says define a word. The word that you're going to define is init. This is a comment called a stat comment that kind of describes the effect of it. This is the function signature, I guess you would say. And what this, there's always a dash in between. It's like before and after. So on the before side, you just get whatever's on the stack, and then on the other side, you get an O. An O means a node in the graph database. I guess because I thought N would mean number, so O is an object. And then the way that object is constructed is we like put, it's like really, this is super high level, right? It looks like it's low level code, but it's super high level, right? You've got this canvas, and you say, okay, put an X0 node into the scene, right? Then put an X1 node into the scene, and put an X2 node into the scene. And when you run it, you'll see that at the very start, it's just gonna. Oops. I do. Oh, I sorry. Oh, okay. That's the X0, the X1, the X2, and then they're also on the stack, and then so that knows how to connect the two. Right, so there's X0, X1, X2, and then of those two, those are on the stack, and so XOR them, and then yeah, it goes by too fast for me to do. I guess I can. How about I stop it, run it, and then pause it? I think I can do that. There we go. Okay, so if you follow this along, we said X0, X1, X2, so that put these three boxes there. And I said XOR, that put this there, and drew these lines. And then the word and draws, so now once it's XORed, so in addition to putting them in the drawing, it puts them on a stack. And then, so these two are the top of the stack, and we said XOR, so that made this little subgraph of these three nodes here with these little arrows. And so remove these two from the stack, and so this whole thing is like one object on the stack. And so you have X0 and then this XOR node, and then we're going to AND them together. And so that's where this comes from. So now this whole thing has been reduced to a single object, which is this node right here, and its subgraph, right? So that's what init does, and that's what this O is. That's the result of that. This is rewrite, so that's a helper routine. So the next thing we're going to call is X0 branch, and so it's going to. You can see this is a symbol. Here's X0 as a function. It doesn't have a little backtick in front of it. Here it's just putting a symbol on the stack. And it says, so we're going to branch. And what does branch do? Well, it takes an object, which is this, and a symbol, which is X0. It assigns a variable called symbol. So that pops that symbol off the stack. It duplicates the object. And dupe is usually in a stack language, it means make a copy of that one thing. But here it's overridden to not just copy the item on the stack, but actually copy the entire diagram. So you get two copies of this diagram, and the stack is now these two objects, right? So you started with this on the stack, you duplicate it, now you have this on the stack, but this is a duplicate. It's an override of that word dupe, right? Dupe is a fundamental thing in Forth, but here it's also doing all this drawing stuff. Okay, so now we can fetch that symbol. We call branch, and branch is doing something internally, which I think actually puts this up here and draws these two lines. I just run it a little bit. There we go. Oh, pause. Got ahead of myself here. I thought this toggled it. Anyway, so we've skipped ahead. But that's what branch did, is it made this dash line and this solid line. See, there's no arrows here. The data is like flowing upward, and here we're just branching based on this variable. So this is you evaluate this when the value is false, and you evaluate this when the value is true. And so what happened here? It set this to true. That's weird. Well, set it to true and say, oh, right, because there was an and up here. So it said and when this is true, one and something is just the something. So this whole thing went away. And it happened so fast that you can't explain it, right? So I want to put pauses in here, right? And I want to have the timeline so I can start and stop this better. So I don't have that ability to pause it here. I could probably put some kind of breakpoint in here and just have it keep starting and restarting. In fact, I think that would be pretty easy. So that might be the first thing I do, just so I can see the steps of this. But anyway, so then we duplicate it, and that's what branch did. And then, now that we have this on the stack, this branch thing, we can refer to its high and low nodes. So in the high side, so we put high on the stack. And I guess usually when you say something, it consumes the argument, but here I guess it doesn't. So because branches, there's already just this node here. So here we're going to push the high node on the stack, leaving the branch there, or leaving this node here. I'm going to say so in this high area, everything that's underneath this line here, we're going to rewrite the symbol that we put, which is x0, and we're going to set it to I, and then rewrite, and now we go into this rewrite thing, and it calls replace, and replace just, as you can see, just changes the labels basically. So it sends that symbol command, symbol message to the node. And then simp, what simp does is it gives you a quotation, I guess. It makes a new function, for this language to do all the steps of simplifying it. And so here you can see that the simplification has started already. The and one disappeared, and you just got what was over here, right? Like this was copied over here, and then this part went away because this was true. Now it says false in this, and so this whole thing was just going to disappear and it's going to become false. See, the whole thing becomes false. Now we're duplicating, and then all right. So anyway, then it finishes that. That's what simplify does, or simplify makes the list of things to do executes that and causes the animation to run. And then now we're up here, and we've moved on to x1 duplicate. So we're called x1 branch, and here we did the dupe, and we just have not yet done the branch part. So if I let this run just another second here, he really got, yeah. So there we go. And now it's going to start setting x1 to false and true. Go. But rewrote this side again. I'm confused because there should be a not here, and I think it's just not drawing the not symbol. There should be a circle above this x0. Oh, there it is. It's above here, so it's not x2. And then it just goes through and simplifies and simplifies and simplifies. Are we done? That doesn't seem right. Oh, okay. Well, there's clearly a bug here because these should not have arrows at all. But I think this is probably the correct truth table. I could be wrong. What are we talking about? We're talking about x0, so x1 and x2 XOR x0. So whenever it's x0, everything on this side should be Oh, I see. All the branches for x0 should be false. And then when it's true, the question is whether or not these two XOR together. x1 and x2. Yeah, I'm just rambling here. This is not useful. Yeah, so here you go right, and you get a false, right? You go right. No, sorry, you go right, you go left, and you get a, so if you go left, you get a false. You go left, you get a true. That's right, because they're different. Go right, left, you get a true, and you go right, you get a false. All right, so that's excellent. I know I'm rambling. This is a terrible video. This video is not going to be one of my greatest hits, I can tell you that. I'm just, I just wanted to talk this out, and I just, I was going to be talking to an empty room. It just helps to talk things out and to revisit the code that I haven't looked at so long. Okay, so anyway, so I have this little mini language that is specific to drawing these graphs, and I want to make videos about these graphs, and this is the tool that I made to make that happen. And I guess somewhere along the line, I decided I wanted to port at least part of that to JavaScript. And so the question is, how do I get there? How do I get this running in the browser? And I think what I said made sense. So I need to take this. V4 can understand all the syntax provided these things are defined. So I'd have to define what x0 is in V4. And what I'm thinking it's going to look like, I can take this right here, move this over here. I have to do it one line at a time here. But say in here. Maybe I'll make a new thing called X for Boolean expression. Okay. So this is not the exact language that I have. So in Forth languages, you usually have a semicolon to end the compiler, but in this language, this is not Forth, this is assembly language. You write this init, and then you can make this a comment if you still want to make a comment. And then to actually put the code, you have to put it back. The end of the line is what turns off the assembler. And so semicolon does nothing, and so you would put this. Okay. And then that's it. And we would say read, write, or rewrite, and that is this. Sorry. Right there. So that's the definition of rewrite. And then this is a definition of rewrite. Now, this doesn't mean anything because these words are not defined. So that turns on similar. It does actually understand this. It understands this is an assignment to a variable called sim. So if we define sim as a variable, we could put a 4 byte plot here. And now we have a variable. We can assign things to that variable, that slot in memory. And then now we're out of the definition mode. These all need returns. Semicolon would file a return. There we go. That's the return. And so now we need to figure out what does x0 mean, x1 mean, x2 means, xor means. We have x. V4 has this XR thing, which is an XOR of 2 integers on the stack. You can say 5, 7, XR, and it'll give you back if you say 5, 5, it'll give you 0. Say 7, that's 3 ones. It should say that's 1, 1, 1. It should give you back 2. Yeah, put 2 on the stack. because the bits of 5 are it's 4 plus 1 in binary, and then 7 is 1 1 1 in binary. When you XOR those together, you should get 0 1 0, which is 2. So anyway, so I have that, but this XOR is not same as XOR, so not same as XOR. Because what this XOR does is actually takes 2 objects and makes a new object. It puts that XOR node earlier. These, I guess. Can you not do that? There's one of those. Okay. Although I think the arrows are supposed to be the other way. All right. So then, same thing for AND. We have an AN operator, but not AN. It's not XR, and this is not AN. Return. So if we define all those, then this will work. Rewrite. So we need to define replace. And I'm just defining them as return, so they're just imp and do, and then dupe. A whole graph, and then branch. I'm reading this now. Sim and sim work, and high, turn, low, turn. And I think what I would do for these, rather than x1, x2 like this, that should be x0, x2. I think what I would do in this on B4, rather than using symbols, oh, actually, I do need those. But rather than using these symbols, I think I would just use a character. So we would say like this. So capital I, capital O, and then just capital 0 because they have to be one character, 1 and 2 and 3. And this little thing was ended up. So right now, these are words that exist in these. Okay, right now these are words that exist in Smalltalk, and they are the words that define these drawing operations. And we can look at that by going to. Oh, hello, people are watching. Weird. I was watching, I don't know if you guys are following the GameStop stuff. I was watching Roaring Kitty yesterday, and he used to stream to an audience of a very small group of people and actually be able to chat with them. He came back after 3 years, and now he's like worshipped. He had like 600,000 people in his thing. He was like, I can't follow the stream or whatever. Anyway, I thought that was fun. So the question was, okay, so somewhere in here, we have something called a Vex RPN interpreter. Oh, I just saw a building. This looks like a documentation building Vex APTs with RPN, ASTs with RPN, abstract syntax trees. I think that this is probably not correct. I think this was old code. Yeah, this is not. A cursor in the scene tracks where the next object has been spawned. That's true. It's called here. Add inputs next to the previous node, and when we add a binary operation, we center the node above the 2 previous items. Yes, that's actually what happens. This is one of the functions. As we go along, Vex creates nodes for us. We should always be able to browse the database of created nodes. Right, because this was meant to be a visualization of my Rust crate Bex. But instead, right, what I'm doing right now is I'm using Smalltalk to simulate that. So I have a very scaled down version of the Bex in right here. So I'm just going to read through here just to remind myself what I. So Bex is the package. We have all these things in it. I think these are gone. So the constants are I and O. For I is meant to look like a 1 and O is meant to look like a 0. So it's they're not the constants true and false. They're the functions that always return true. So like and takes two inputs and returns a 1 or a 0. So I is the function that always returns a 1. O is the function that always returns a 0. So it's the functional versions of the 0, like const false and const true in or const 1 and const 0 in Haskell. A definition would be I didn't comment any of these things because they were all just like I did this very quickly. This was all like experimental code. So aside from that, we have a variable, which is an input, x0, x1, x2, and so on. And then we have definitions, which are nodes that define like a subgraph. So like as soon as you do an and of something, then now you've got a definition and of the two things. All right, so Bex base always refers to it refers to an array of nodes. So nodes and nid should be nodes would be a list of these definition objects. Nids would I'm not sure what nids is, so let's see what initialize is. Weak identity dictionary, identity key dictionary new. I'm not sure what that does. I don't think. Yeah, it looks like this was a scratch idea. This is not implemented. I should probably just delete this, right? Because it looks like I have Bex scene base here, and it looks like that was meant to be like a. So this is scratch, which is no reference in two places. Where? Oh. Okay, so maybe we've got some stuff going on that's like not properly encapsulated here. Because it's referenced by things, but like it doesn't do anything. Oh, that can't be right. Oh, I know what's happening. We replace this with this, yeah, scene base. Oh, this is the Bex scene base. I was expecting to see. So inside the Bex scene base, might have popped up a new window, but I see all the references to this. How's references to this? And then where is this used? I want to see the how's references to this. Well, this is not my stuff. I think this is just not. Yeah. I don't think this is ever called. I don't want to like. Okay. So my impression is this is never used. Look at that again. Browse references. Initialize. Yeah. So it's only called an initialize. I think we can just get rid of this. there's no reason. The idea was that I know what I remember what I was thinking. Like the idea was that the scene base would actually talk to the real database, right? The real database of these things. But I like this is clearly not doing anything. I think this is just gone. Two places are where scene base initialize. Okay, so this is, I think this is a Bex scene base, and we're done there. And then this is also a Bex scene base, done there. And now we can delete this because this will be delete this, not reference. Okay, boom. Okay. Now we're looking at like ungarbage collected stuff. All right, so Bex Canvas, I think that was probably a real thing, maybe. Oh, maybe. Think what to do here. Well, let's see what how do we see references? Use this in such a browser. Constant example. Okay, so that should draw. That doesn't look like it's a very good. That I don't think this is a real drawing. Here's the drawing. We made a space for it. Made an example. I don't think this doesn't look like what I'm actually using, right? So I think what I said is I started making this, and then somewhere along the line I said, "Hey, wait a minute. Why do I need to make my own canvas when I have this drawing tool that I've already made?" Because so this has got to be garbage. I think this is garbage. I think so. This is a real thing. This is a real thing. It has its own canvas. It's a tool app, so it has its own scene and everything. So I'm using my drawing library to make this happen. Scene base, yeah. So a sketch app displays a scene. A tool app displays a scene. A scene base has. Oh, finally something with a comment. Yes, this says I'm a wrapper for Backspace, but we don't need to actually wrap it because I didn't actually implement any logic in there. So hypothetically, it could be a backspace, but there is no such thing as this. I'm just going to draw that. I am a graph database that draws my contents in a scene. That is. It uses a node shape and and the interpreter. Okay, so I think these are real. Node shape, edge shape. The graph tool is the thing that the sketch app is going to employ. So initialize tools, yes, it uses a Bex graph tool. So that, all right, so SketchUp is good. Scene base is good. That is what is, it's like an X, so this is displaying the visual aspects of it. This is displaying, or this is controlling that scene in a different way to, draw, to figure out what should be in the drawing or whatever. RPN interpreter, that is a real thing. So this is what is interpreting that language. The node shape is what's drawing those things. The interpreter events are used for stepping, and as the interpreter runs, it sends out these events so that the GUI can respond to it. The interpreter done event sure looks like it ought to be an interpreter event, don't you think? So maybe I can make that. Can I drag it? No. I bet I can make it change the superclass to X interpreter event. I'm just trusting that this doesn't go. Look at that. That was the wrong thing to do. Okay. Wow. Okay, so am I in this interpreter over here? Let's see if I can stop this. Sure it's not running anymore. Ah. Okay. All right, let's look at this and see what it's doing, what it's telling us. So redraw stack frame called something. And index. Oh, so I've lost IP somewhere. All right, so we should say IP if not nil, then do all this stuff, right? Because assuming the IP is nil, right? So IP is no, IP is 2, and index between 1 and self size. And the error was between and was sent to nil. So at index was sent to nil. Stack frame children at IP. You go here, and index is nil. And here, IP is 2. What? That does not seem right. That doesn't seem plausible to me. What is stack frame? Horizontal flow, stack frame children. Turns a child collection, right? Okay. I'm not going to save this. I'm just going to close this. This seems wrong. I think maybe we just got past all the. I don't know what's going on. I think maybe. I think maybe like I bet here. Like this is live data, right? So IP was well, it must have been nil at some point. The instruction pointer must have been nil at some point. Okay, so I'm just going to close all these windows. Hitting Alt Tab and just closing all the hundreds of. Problem with development in Smalltalk, right, in Pharo and Glamorous Tool. There's sometimes you just have chain reaction where 100 windows pop up. Okay, we're good. So I think something I did when I came back to this thing and I hit stop or whatever, like it reset it. Right, not a problem. All right, so I'm going to run this now, see if I get a million error messages. What's happening? Oh, something's bad. Okay, but nothing crashed. Nothing did. I don't see any other windows here. Something is And I can't. Hmm. Okay. Kill it. Kill it that way. I'm hitting Control Shift Escape to bring up the Task Manager in Windows. It is taking its sweet time. It's not responding. We're taking up 8 gigabytes of memory. Is it dropping? It is dropping. If it keeps dropping, I'll just let it cool down, but no, it's not dropping. So let's kill it. Fantastic. This happens often to me in small talk. Not often, but like, several times a week this will happen. And we're down to 162 meg, but we still haven't finished the process. Maybe I clicked the wrong thing. Is there a suspend option? It's end task, right? What to do? Or up to a gigabyte. I didn't hit. There's no suspend here. I told it to end. Okay, it's not now. This little extra. Okay. All right, let's try that again. So let's launch Glamorous Toolkit. So Lil does not have this problem. Decker, I've got Decker to freeze up like once, but for the most part, it does not do that. All right, so I've lost all that data. I can recover that from code changes. So okay, so it says we deleted this. I think I just want to recover latest. I do this. Apply. Confirm. So it like kept a log of all the things I changed, and now I've applied it. So hopefully, okay, hopefully I'm done now, and now I can go back. And the question is, does it still work? Okay, I should have the task manager ready just in case. Oh. That change was not good. I'm just gonna kill it again. That should come up instantaneously. Task. Go one more time. do this. Sketchup comes up super instantaneously fast. All right, so I'm not going to make those changes. Oh, maybe I can do them one at a time and then make sure that everything works. Like the idea was to simplify this. So okay, so what you do is you have this ready. Say Vex, and we should see the package called Vex there. And this way, if this crashes, then now we can just get back to this point real quick. Save. And we could inspect the changes and just try and apply them one by one, but it's not going to do that. All right, so this. I think the idea was that Vex space was going to be like an abstract thing. We definitely don't need this canvas. This is gone, right? Reference in one place. Where is that? Const example. Okay, so we're happy to delete that because that's an example of something that does not work. So we just delete that. Boom. Now we can delete this whole thing. Boom. See. Okay, so now we're looking at the package again. So now we can save this. The debugger panel definitely exists. So when we run this, hopefully we have the debugger panel here. If we pause it, right? So you have to run it while it's in pause mode, and then you can hit step. How do you do that though? I think this one just shows what's going on. It just shows it. But this one here, you actually have a. Oh, I never added any kind of like interactive thing to it. You just run this. There you go, and it causes this to move. Okay. Right. So this is the debugger panel. So that's a real thing. Edge shape works. Vex examples. Yeah. So I had this a long time ago. So this was. Here we got like a. I think I did this like even before I did any of my drawing tools. And so when we said and I think this is old junk, but I think it's like I think I'm using it to like draw like some diagrams somewhere. Like this is something I did like just as a drawing tool a long time ago. Yeah, Vex const. I know these were like drawings I made. So if I do, I may not even. Yeah, I think this is like I don't know how to see the date on this, but this is like way old. This is like one of the first things I did in Glamorous last year. And there, I deleted that. But I think this didn't work. I'm just going to delete this page. This page does not matter to me. This. Whatever this is, this doesn't look like it's up to date either. The Vex shape doesn't. But yeah, these were just old like drawings I had. I guess I should probably just delete that too. Or you could say, we'll just change it to what it actually is. Bex. What was it called? The Bex node shape. And then new. And the symbol is that. And then so when I run this, it should draw something. There you go. Okay. I don't know if I need to keep that. I don't see any reason to keep that. Whatever. So let's save all this. So again, I think this is garbage, but it does have references. One of these could be the thing that caused the problem. But I don't think so. I think if I remove this, it's fine. Browse references, because now we're looking at a variable, so this is only going to be inside the scene base. I'm going to remove this and have this return an exception. So if anything runs this, how do I do this? Say, I don't remember how to throw an exception. Arrow, small talk, throw exception. It's not just part of the self error. That's what it is. So self error and it's error with this. Self error thing is apostrophes. Self error. This should not be called. How about don't change the base? They deprecate. And so if that gets called somewhere, then it'll post an error. And then otherwise we can delete this line. Now the Bex space new is never going to be used. Okay. How did I get to this? So these are the two, okay, so we say right click, browse references. These are the two references. Now we only have one reference. So we'll use the Bex scene base instead. I think this should all be safe. So let's try this. And again, we go here, Bex Sketch App. Everything came up just fine. Run it. It looks like it's running, so I think that's all good. So save this. I think for whatever reason that exception it's the exception that caused them. I moved it underneath the X package. I filled the package. And I moved this interpreter done event. I made it a subclass of Bex interpreter event, and for some reason that screwed everything up. How can that be the only reference to that? Look at that cute little icon. That surprises me. It makes me think that this is not used anywhere. It's sent, but it's not trapped. It's not caught. So nobody's listening for this event. Anyway, Bex interpreter event, what is an announcement, right? I don't know why this would break anything. Well, let's try it again. And maybe just because it was already running, we'll try it this time, and we'll change this to, so change the super class to Bex interpreter event. Save it. I'm not going to save the image. Oh, look at that. Why would that happen? Why is this being called? Why is, oh, because is it, okay. Like that really surprises me because the program's not running. Like, why is that being called? Show this. You have these, you can see kind of all the processes or whatever running. But I don't think, like, I don't fork like a thread or anything. Oh, look at that. Can I clean that up? I'll close all spaces. Fresh. Okay, so now it's gone. I don't know why Lepiter is this. I don't know why it says it's dead. But okay, so maybe, I don't know. Let's save this now that that process is gone. Try it one more time. Without starting process, what do? I would do that same thing again. Look at for Bex. Clearly, you can't mess with that class while it's running, but I want the package. Whoa! Where did it? What is this? One more time. I don't know what I did there. Yeah, this is what I expected to see. All right, so interpreter done event. Now with that process gone, I think I ought to be able to change this without consequence. X. Right, no problem. All right, but just to make sure, now let's run the thing and make sure nothing blows up. Oh, it does. Okay. It doesn't bother me that it's not a it doesn't bother me. I guess maybe it does bother me. It currently bothers me that the interpreter done event is not a Bex event, right? So okay, maybe that can't be the case. But if it can't be the case, I need to document why it's not the case. Right, so comments. Why is this not a Bex interpreter event? It seems to have a problem with the trying to make it a subclass currently causes a cascade of debug windows because the IP field I almost want to do it again just to figure out what the exact error message is, because this doesn't have an. I think this does not have doesn't have an IP field, but I think this one. Oh, I see. So this has IP. What needs to happen in order to make this work is that this needs to have an initialize method. That calls super initialize, and then sets IP to 0. So you have a default IP address, or yeah, instruction pointer. Because it seems like wherever these get sent, these are being invoked. If we look for the browse references to this, yeah. So when we reset this, we set a new one with the instruction pointer set somewhere. But when I send the other event, then that's becoming empty. So now that I've added this line here, I now believe that this should work just fine, because this will be set to 0, and then that between will not fail. And so then I can just remove this comment. Sent when the interpreter stops. But it's weird that was being sent at all. Like, why was that floating around? Why was that being sent? Where is this being called? Yeah, this is the only place it's being sent. But maybe this is being sent on each frame? Like, if there's a sketch app running in the background again somewhere, and it's not paused, then maybe the step is being sent on each frame? I don't know. Yeah, return is not a small talk thing. I got to look at what this thing works. This is not my virtual machine, right? So I'm using this simplified version of a 4th virtual machine. All right, whatever. And there that guy is again. Like, why does it say it's dead when this is like clearly alive? Friend is only mostly dead. Mostly dead is partially alive. Billy Crystal, this bride. All right. All right. Anyway, I think this is safe now. I think that by setting a default IP instruction pointer, then we fix this problem. And again, not that this needed to be done. It's just like why isn't this an interpreter? Just a way to get back a tiny thing, but just cleaning up. I think is a good way to get you refamiliarized with it, or to get you back up to speed with a piece of code. Right, yeah, that seemed to work. So no blow ups here now. Right, so we can save this. Now I think now this is going to tell me that it's not referenced, and now we can remove it safely. The intent was that that there would be like a Bex base that was actually talking to the real Bex application in Rust, and causing things to happen there, so that rather than just a little toy thing that you can animate, the animations work great when you have like 5 nodes or 100 nodes, 1,000 nodes. The real thing, the real Bex works with like millions of nodes. You can't draw that on screen, right? So the idea was that you would have the same interface for a toy example that you can draw on the screen, and then the real examples that would just run in the background. But since I never implemented it, let's just get rid of it. All right, so edge shape is good. That's just a basic line that extends from GS edge shape. So GS is my drawing package. And then it has this, one of the endpoints is a circle if it's inverted. The graph tool is used inside the Sketch app to construct the graph. There's a GS graph tool, and then there's a Bex graph tool that allows you to draw with a particular symbol. So when you click graph, you can just draw these by hand now if you want. So you can say, I want to draw a false, and here's a, oh, that's weird, true, and then next time we're going to do it, we're going to put a branching up here. So yeah. That's the idea. So that's this thing is the graph tool, and I guess it adds this thing to it, so that to the base graph tool, so that you can select from a palette of kinds of nodes. It's like this is the whole language that I'm going to be using for the videos, right? It's only, these are the only things that appear in the diagram or in the language for now. Maybe in the future there'll be more binary functions. These are main ones. It's a really fairly, this application of drawing for Bex is a relatively small language, right? So it ought to be, I don't necessarily need all the drawing tools. All right, like I feel like I have a pretty good idea what all this is about now. So let's check this code in. Git tspharaoh. Oh no. The question is like, how far behind am I? I don't think, I'm probably not very far behind, right? Like, it's probably, well, the right thing to do would be to commit this, right? So let's commit this. Really don't want to do this again. What are the commits? Fix baseline, okay? I go to github.com and storm tspharaoh pull request. Oh, right. Stefan Egermont implemented something. I should give him credit for this, because I implemented something different and he sent. I didn't. I merged his fix, but in a different way. I need to give him credit for that. Okay, so all right, so I'm up to date. This was the same thing. Thanks, guys. I can so changes, commit, clean up unused Bex clean up Vex. Okay. And I push that. It might tell me I don't have. Oh, I guess it remembers the password. Gave it a key or something. Okay. So the other reason I didn't check that in exactly is I was going to break this all out into its own. I was going to break all this drawing stuff out because like this was like a scratch repository. Now I have all these like an actual application in here. I don't need this. I don't need this. I don't need this anymore. I'm going to save this because I want it to get out of sync. Wouldn't get out of sync. Well, I guess if you make changes and then you commit them in Git and then you don't save the Smalltalk image, then now when you load up Smalltalk again, you don't have the changes that you've committed, and so you're out of sync. All right, so did that help me at all? Like, did I make any progress there? What I did was I just cleaned this up a little bit. So that's not really so much progress other than just getting a better understanding of what this thing is. So the Sketch app is the thing that you're talking, you know, when we go here, this is the Sketch app. And it has an RPN method that just returns this RPN member. And the RPN member is just the is RPN interpreter new. And then we do it in like two steps. So we super initialize so that we have a scene, and then we tell the RPN interpreter that its base is this new vaccine base that uses RC. So we have the two things looking at the scene. One is the Sketch app itself so that it can draw it, and one is the interpreter so that it can make changes to it. I think let's see. So Beck scene base is I'm gonna hit control on this so we can view that class. It has a scene, it has the position where we're going to draw stuff, as a reference to the RPN interpreter. I think we decided this was never used, so I'm going to go ahead. I never got it. I never got this message. I'm going to delete it. This scares me. Right? I think nothing else changed there, but let's just double check. It scares me that it's deleted like a bunch of references, but no, it hasn't. Like this, it says this method got removed, but nothing else got changed. So it wasn't like a cascade here. So now we can remove face. Okay, so back to initialize. We have scene. I didn't go back to initialize. So it has a scene. It has here, which is a cursor position. This is the place where we're going to put the next node as we draw. This, what is this? Yeah, find references. This. I see. So this is like the thing that we've just made. Yeah. Like the thing we're returning. It's like the top of the stack or whatever. What am I doing here? I guess I'm picturing the idea of taking this Smalltalk thing and mapping it over to a JavaScript thing. And I think I guess the question is like, to what extent can I just replace the word scene here with like an SVG node, like a SVG element in the DOM here, right? Like, because if that's the case, if I'm not using anything special about like Beck's node shape is just a you might want it to be a custom element. What would it be in I don't. Okay, so the problem I'm envisioning is that custom elements, you can have the way custom elements work is that it's tricky when you're doing SVG. You can make a custom element that is an SVG. Um, Probably I don't think about that at all. Probably I just have like some data floating around, and then I have an element, custom element on the JavaScript side that is a like a graph drawing thing, and then and rather than like trying to do something in the okay, so I'm in JavaScript land. So again, I'm trying to unify these two worlds. So in this world over here, I've made a bunch of custom elements. So everything you see, like this window, is a custom element. So I have a interesting that there's obviously some bug with the scaling or sizing or something here. It's supposed to used to be attached. Oh, I see. It's because I'm inside this thing. Somehow that's, you know. Um, hmm. All these documents. Yeah. So I got some issue with this. It's not dragging correctly. You can see my cursor is floating under my cursor. That's a distraction. That's something I got to figure out and work with. Anyway, but like the tabs, that's a custom web element. If you look at the code for this, expect, right. So we have a UI win, which is just plain old HTML element, right? And then inside of that, we have UI tabs. And so that's something I made. And the UI tabs have a UI tab called FS and one called FS Waves as well. So anyway, and all the magic happens in the shadow root. And so, what am I getting at? I guess the idea would be that if I made a custom class here, a custom a web element, then I would have something that said like Vex graph or whatever. And then inside of that, if I wanted to, like I could just write, what would it look like? Let's make a new snippet. It would look like this, right? This is JavaScript. But it's going to highlight weirdly, but it would look like Vex graph. And then you would be able to say like node symbol equals I, and then X equals the X position, Y equals the Y position. And you do have to put these little closing things in. So maybe this would be like I0, and this would be A0, this would be X0. But then it would say like X, it's more like X00. And this would be and then this would be whatever. And then the edge would be from maybe you could even use the logic itself to, the layout logic itself to do that, right? But what I know I'm not explaining everything that's in my head. My thought was that, like, what if you could even without these, to draw these things interactively, I don't need any when I write the program here, I don't need any like references to these things because I'm using a stack. So what if this were like a stack, right? And I mean, if you wanted to, if you really wanted to, you could just say I and I mean, really, if you wanted to, you could just put I and X0. No, you would say I. You would put exactly what's in here. Well, could I do that? Could I just have Vex graph and then just have it be the text? And then you paste the text in, and when the text changes, it regenerates the graph? I kind of like that. Like, what if the interface is just like this? Down here. I mean, this language doesn't exist yet. This language is like a fourth derivative. It doesn't exist in JavaScript land. And the idea would be this could run on top of the virtual machine, V4 virtual machine. It would be a little fourth interpreter running on top of the virtual machine. Or I could just, have this translate to, it could be in JavaScript and then just trigger things. I just haven't implemented the fourth yet, right? But I'm pretty close. Like, I'm pretty close to being able to implement this word and these words and stuff. But this would trigger an animation, right? Like this would actually do the animation. But maybe what it does, maybe what this does is it builds the animation, but it also produces a timeline. And so then you get one of these things. You know, you could do something like what is it I'm looking for? Keyframe demo. Like it could compile all this or execute all this, and then instead of just generating instead of just generating the stuff, the SVG in real time, it could generate a timeline. Or whatever I'm looking at here, I forget the name of this thing, but this would be a timeline, and it would have, so you'd be able to scrub back and forth on this entire animation. And the way that works is that you've got a bunch of like SVG elements. So like every node that appears in the scene has to be pre-generated, right? Like so it generates this, and in doing so, it will have to like like allocate all the nodes, and then instead of creating them, I mean, well, it will create them as it goes along. Right, so like as it hits this, as the interpreter hits this, it's going to create an X0 node, then an X1 node, an X1 node, an AND node, and all the associated edges. So 4 edges, 2 edges here, and 2 edges for the hand. And then when it does BR, it's going to do the dupe. It's going to make, so you've got what, 1, 2, 3, 4, 5 nodes and 4 edges, and then when you do the dupe, it's going to have twice as many, so 10 nodes and 8 edges. And then when it does the branch, then then you add 2 more edges and 1 more node. Anyway, the point is that now, at that point, if you scrub backwards, what happens is that those things don't get destroyed. They just have to be put offside. So it's like you got to make a timeline. Like conceptually one of these things. I guess the Bex one doesn't show it, but the player app. Ooh. That's broken. But the Sketch app has this thing on it, right? So it would have to make a track for each one of those things and just have them hide it. I could do this in Smalltalk, but I want to move the builder to JavaScript because the browser already has the concept of a timeline for CSS properties. And I think everything is a CSS property except for when like a node changes from, like the text of a node changes. But maybe I could simulate that by either triggering a chunk of JavaScript or like maybe a node is a SVG symbol or something like that. And then it would just have like this, the children would have one of every possible label. Because again, there's only like, it's just the letters of the variables x0, x1, x2, x3, true, false, and then a couple of expressions. So you could have a text node for each one of those just centered in the right place and just only show one of them. And then, so then the CSS transition would be to hide one and show the other. So okay, so to recap, what I'm saying now is that when this is added, there'd be a CSS, there would be a web element that is hooked up to a B4 virtual machine. And the first thing it's going to do is execute the code. We have the scripting language that executes all the code. There's going to be a custom device that is drawing into this shadow DOM, that is drawing on an SVG canvas, doing all the things that the Smalltalk version is doing, except using SVG instead of Smalltalk objects. And then as it makes changes as it goes along, and it says like rewrite and replace, what that's going to be implemented in as is not just, well, what it would do is it would add a new keyframe. There would be a certain point where we add a new keyframe to the animation. I think I don't remember how the animation works. But yeah, I'll have to look at this to see how to. I think it's like global, right? So it's like you don't have like any kind of weird nesting or whatever. It's not nested timelines. You just have a new keyframe, and then you would set properties for each one of those items for whatever you changed. I know I'm kind of rambling here. I could also prototype this on the Smalltalk side. And so this is leading up to kind of the decision I really wanted to make today, which was like, what am I doing here? Am I going to implement, like, how do I make this transition, right? Because I see I have code living over here, which is like the new host container, and then over here I have code that I want to migrate, and the two are very different. They're slightly different, right? They're similar but different, right? So on both sides I have a Forth-like interpreter, but I came at it from slightly different angles on each side. And so the question is, well, how do I make it as easy as possible to migrate code back and forth between these two environments? And if I had this little language here, that would make it easy. Then I could play it on one side, play it on the other side, and it wouldn't matter. And I like that, right? Because if something doesn't work on one side, I can do my debugging one. But the question is, how do I do that? Because on one side I have like I call it empty Forth, where it's like, it's a Smalltalk interpreter. It's an interpreter written in Smalltalk, and it deals with Smalltalk objects. And on the other side, I have this very low-level language that's dealing with characters and bytes and integers, memory cells, and pointers. And so the question is, do I implement B4 in Smalltalk? I plan to do that anyway at some point. Or do I try to make the graph builder in here and just make an object, or just make something that I, again, can. So I can take this code and just paste it in over like this. I don't have a place to. I don't have anything like this. I don't have a widget like this that lets me take an entire list of lines and run them all at once. It would be easy to make one in this environment. I just haven't done it. I can only run one line at a time. I'd have to. I mean, I can do that right now. But the point is that if I had that widget, I could just copy and paste this, and it should do the same thing, which is nothing, right? But it should execute. This should be fine, right? It's going really slow because every time I have it set up so that every time it executes anything, it runs this. But yeah, I didn't get any error messages or anything. So this all worked, quote unquote, worked in that it runs, except these are all empty things. So this actually ran this line of code right here, and you can see it. These are the hex codes for the letter 0, the letter 1, and the letter 2 because they didn't do anything with this. They just got pushed onto the stack. I don't know if the 2 came from. I think the 2 is from something I did earlier. But like these all compiled, and like here's the definition BR somewhere. I gotta make it so that when you click on this, it jumps to the right place. What is this saying? BR. Oh, I see. So it's loading the address of sim, right, which is right here. Yes, there's the sim is at 637. So here's the 7. Here's the 63, which is. No, sorry, it's the 37 is apostrophe 7. Right. So 3 something is, yeah, that's what we're saying. And then the 6 is control F. Yeah. I've gotten used to reading this. This is nonsense. This is a memory dump of the virtual machine. Anyway, the point is that this code that I took, that I translated from this application drawing language to the pure B4 assembly, or B4 B4 interactive, worked just fine. I'm able to run it. It all quote unquote works. I just have to fill in what these things do. And the idea is that the implementation of this would be add a new device called the graph builder or something like that, and that would be just a new op that I extend the thing, so there'd be a GB over here or something. Graph builder, graph base, something like that. Called BX for Bex, I don't know. And then that would be a command that op would interact with this hardware device, and so it would take something off the stack like this. So it would, load byte 0, and then there'd be a command to the graph base. So it would have load byte 0 and then load byte 10 for node or something. The way I've been doing it is I pass these little single character mnemonics to the thing. So like I think I showed this earlier, like for the Canvas database or the Canvas device, quote B draws a box, and so you would have quote B and then CV, and then before you call that other stuff would have been put on the stack. Same thing with like here the terminal. I have all these little terminal ops. So load the byte G and then call the terminal thing. So that is expecting an X and Y there, and it says go to these coordinates. A sets, take an attribute and set this terminal. So the A, you never have to type this. So rather than typing this, you just type TA, and it looks like it's a single op. So then for everything that you want the device, this virtual device to do. In this case, I call it a hardware device, but it's like a library, right? It's like it's some kind of complicated thing. It could be an arbitrary complicated thing. Like here, here, the canvas device, draws a circle. Oh, okay, it's a good example, right? The canvas, you probably don't get a hardware device that draws a circle. You get a hardware device that draws pixels, right? And your GPU doesn't really know about circles either. It knows about polygons, and it knows about triangles, and it knows about and it has some complicated thing. But even going back older than that, like your monitor doesn't know what a circle is. It just has a CRT days, it had a thing going back and forth, and cathode ray was going back and forth, and then depending on the signal you send it, you sync it up, and it sends colors or it sends different wavelengths that activate the pixels in different ways. Point being, hardware devices can be very simple, but in this world, like, you can make a hardware device that has a circle operation. So this canvas device here has a circle operation, which is draw a circle, which is C, right? So it takes a radius and then draws a circle, and you have a fill color and whatnot. Fill color, dimensions, and rectangle. I think dimensions are dimensions of the canvas. I don't know. So I'm just reading what this says. So to clear the canvas, this is the number to use to fill it. So set the fill color to 1. And then you're going to draw a rectangle from 0, 0 to the dimensions of the canvas. And so this is executed in real time. And so if I execute this line, hitting Shift Enter, that canvas is cleared. I draw a circle. Boom, there we go. Draw again, blah, 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 blah. Anyway, this probably could have been encapsulated as a nicer little thing, but function to draw a circle. Whatever. I did this when I was first figuring this out. Point is that you can make a device do an arbitrary complicated thing, right? So it's not so much a hardware device as it's a library that you plug into this thing, and that's what I call a virtual hardware. So in my mind, drawing this graph, like drawing one of these things is a, if I pause this here, let me run this, and I step through it. Yeah. So every time it did x0, x1, x2, like that could be a primitive operation that there we go. And if I step again, why didn't it draw x3? What happened? Seems wrong. Yeah, XOR and there you go. I don't know why it didn't do that last time. I must have screwed something up. I forgot where I was going. Oh, anyway, so these are like primitive operations, right? So the virtual hardware device can do anything you want, like draw this entire graph and keep track of where the graphs are. So each one of these are quote unquote primitive things. So so maybe then in this world, if we go back to where I'm trying to copy this, right? So yeah, so I already did that. So maybe when we draw x1, it's load the byte 1 onto the stack, or the character 1 onto the stack, load the byte, the character for n onto the stack, and call the call this Bex, right? The X for Bex, Boolean expression. Right, so now I have to define, like, all this is now valid, but I have to define Bx, and that's probably an op. This is a new custom op in host language. So in JavaScript. So the idea is you can run it in different, like, I could draw it here too. I could have Lil or Decker draw the graph for me. All right, so I'm just documenting what this does. So Bx, so nBx creates a new node. So sim with symbol s. And so that's these. And then this is these would be the same kind of thing. And again, we'll use like one character things for them. So that'll be n term. All this would be the same thing. So we'll use X for XOR, A for AND. There's also OR. Okay, so that would be our mini language there. And then we need how about we'll say it like this, and then we'll put the stack in. So it takes a symbol and returns an object. Object is not a concept in B4. So O here in stack in signature, stack effect right here, indicates stack effect. Indicates object reference. So it could be a number, probably a number. Just a number. So then we want RBX for replace. Bigs. I think these were documented in here. No, they're not. Maybe in the RPN interpreter. X RPN interpreter. So I'm looking for replace. Yeah, so it takes a symbol and a value. So let's see. Oh, big O is modified. Modified O. Modified or new O. S is a symbol, also a number. Here a character. Character in B4, or character right. And I guess we want to put. I can't call I. I can't call. So in B4 you can't call it capital I. You call it lowercase I. But I think there's actually a bug that will not allow me to do this. If we can. So if we say I 1 2 3 4, shift enter. Yeah, it doesn't like that. What we call II. We have II and OO. One letter characters are used for registers. There is no lowercase I register. There's uppercase I register. Anyway, so we'll call them II, and we'll load the letter I, node return. OO, load byte, O, Oh, we've already got O. So we use uppercase and lowercase here. Load by, yeah, right. EX return. So uppercase. So OO will put uppercase. Right. Like these are the labels I'm using. I only have one character to pass around, so I'm going to call it. I mean, I could make a. I could use it 4 bytes for the label, but I don't want to. So I'm use a single character, and so since I only have single characters, I'm going to use uppercase I, uppercase O for true and false. 0, 1, 2, 3, and so on for the inputs. X0, X1, X2. X for XOR, A for AND, O for OR. I think that's the only ones I use so far. And so S is a character. Okay. And then V. V is what to is any value, symbol or object. All right. So replace takes an object and a symbol and a value, and replace S with V in O. And that does the rewrite part, and then SVX I will call this, I'm going to capitalize this node. I'm going to replace, I'm just going to capitalize the word replace S, and this would be it's going to take a node and it's going to simplify the node. That simplify node O is, oh no. I'll have to think about that. I forgot that. By creating a quotation, so in a quotation is just another function, right? So it's the address of a series. So in V4, any one of these that you look at, these are all just like bytes compiled into RAM, and that's a table of opcode names. This are all the opcode names. And so they're just laid out in RAM. So the address of a sequence like this that ends in RT for return would be an anonymous function. So a quotation is an anonymous function. That does all the steps. I'll call this Q and reference up here. Q is quotation. The reason for that was so that, like, the process of simplifying is, oh, well, what does it do? Let's see. Base simp. So the RPN interpreter calls scene base simp, and this is a complicated function. What does this even do? Can I make this bigger? Yes, I can do this. Hey, come back here. Crowbar is not cooperating. All right, so what does this do? very finicky. If I try and drag it, it jumps like massive amount. And if I use the scroll wheel, it jumps a little bit, but still too far. Okay, so this is in the scene base. What this does is it takes a node and it's just going to say simplify it. So this is a bunch of simplification rules. Presumably this is a recursive thing. I would think it is. No, it's not. No, it has to be recursive. Well, I'm not seeing the recursion yet. But I expect it to be recursive. All right, but let's just walk through it. Why do I have this tick thing? So tick is a function. This is called a block in like a closure. So it's a function that takes a variable called I, ID from number i's. So it just creates a symbol. Oh, maybe the tick is for the back tick. Like that's a weird name. Usually when I write the word tick, it means something like a, like stepping through something like a clock tick, right? Okay, so this just puts the back tick in front of a number, and that's the symbol. Okay, so ID from number. If you pass in the number 1, I think it actually says ID 001, and then the backtick in front of it makes it a symbol. Okay, anyway, it's just internally tracking the symbol name. Sims, a node arg symbols. So for each of the so the nodes know their arguments. The child nodes, right? Like each node in the diagram is annotated with a set of arguments. So like if you have an and the two things pointing, the two inputs to the and are the args, and then we collect the symbol. So we just ask each one for the symbol. So the index of I is, we're simplifying a node here, and so we're looking to see, is there a constant in this node? So is there an and I or and 0, something like that? And if so, what is the index of it? And then we have we have the index of I, index of 0, and then has I, has 0. If the index is -1, then we don't have that thing. Or I guess in Smalltalk everything starts with 1. So if the index is greater than 0, then we don't have it. So the index will be 1 or 0 if it's not bound, or 1 or 2 or 3 or whatever, however, depending on how many arguments you have. So far, everything has either 0 or 2 arguments. But you can have, like if you do a 3-bit adder, you use a 3-bit function called maj and majority, and a 3-bit function called like a 3-way XOR called parity. So one is the result, and one is the carry, majority and parity. Anyway, and so those could be nodes that has 3 inputs rather than 2. But I just haven't done that yet. I haven't drawn a picture of that yet. You can have arbitrary number of inputs. And sometimes when we're simplifying things, I want to get to the point where like you can hold a 32-bit truth table in a 32-bit register can, or 32-bit array of bits, right? An array of 32 bits can hold the truth table for a 5 input function. 2 to the 5th is 32. And so in the Rust code Bex, I expect to replace, or I want to do this optimization step where I, instead of drawing the whole graph of with 5 different branching variables, just have like a little, like I wouldn't store that graph. I would just store the truth table, because that's smaller than a pointer. Anyway, I'm getting off topic here. Other than the fact that these are things that I would want to animate, right? So there could be at some point you've got like a 32-bit icon or whatever that is representing a function that is some arbitrary function of 5 inputs that you might want to show on the screen, and then show how that reduces or can be isomorphic to the graph, which would be really great to show if I would demonstrate. Like I always have these little things that are just in my head, and I want to show them because they make so much sense if you could draw them as a diagram with an animation. But that's what this tool is for, and I just haven't gotten that far yet. All right, anyway, enough of that. All right, so case is something I added to Smalltalk, called this Pharo Smalltalk, so Pharo, and then Smalltalk has never had a case statement, so I felt a little bad adding one. So I called the thing that provides the case heresy. Anyway. Anyway, so case, whatever, case the symbol of, so based on the symbol, what do we do? And then we pass it in a dictionary. And so if it's a constant, so if it's I or O, that can't be right. Yeah, I or O includes self. So, okay, so what is it doing here? So the list includes self. So is it a constant? If I got something I added to the symbol type, now can tell if it's a Bex constant. So parent edge is inverted. Oh, I see. So yeah, so the edges in a Bex diagram have you can draw a circle on them to make them inverted, and so if it's inverted, then we're going to remove that inversion, because normally you would, if you have a complicated graph, you don't want to store the whole graph plus a copy of that graph for when it's inverted. You just take the uninverted one and then you invert the edge, right? So like you just put one bit on the edge, and that actually is something you would do with the constants as well, but I just don't draw them that way. Rather than drawing an inverted edge to true, you just pretend that there's a separate node for O and I. All right, so that's that. So that simplification just removes that dot if it's a constant, or removes that circle if it's a constant. If it's a literal, we don't simplify it. We can't simplify it in any way. So x0 is always x0. There's nothing else you can do. And not x0 is not x0. And we say has 0 if true. So if the node we're looking at if it has a 0, then then we take that 0 and replace So if we're saying and 0, then the whole thing becomes 0. So self replace node. All right, so self the diagram. So diagram replace node, or the scene base, replace the node we're looking at with the argument in the slot that is a 0. So just replace it with its the index, replace it with one of its arguments. And if it has a true, then we're going to replace it with the one, the other branch. And then if you have two things that are the same, then that should reduce to just x. And if you have x and not x, that should reduce to false, but I just haven't done. So I think there is no recursion here. Oh wait, no, there is right here. It's simple. Yeah, so really these should be recursive as well. But I just didn't have a need to animate anything recursive that way. Because it could be, you could have a complicated expression in the word, you call this after you've replaced a variable with a constant. It's like setting x0 to true or something like that. And so then you could be anding two giant subtrees or subgraphs, and then now you might have a lot of stuff you need to recursively simplify. But I didn't do that because the example I was using didn't do that. But here, where I have a branch, then I did do that. Yeah. All right, so that's fine. I mean, this probably needs to be generalized a little bit. But this needs to be like this needs to be the simplify. And it's also creating it says creating a quotation. So here in this world, a quotation, you see it's a list. Sorry, wait, hang on. This right here is a dynamic array. So this is like return from this thing, a dynamic return something. The caret says return. It's like a return statement. The curly braces are is an array. And here we're saying basically this becomes an array of symbols because each one of these things evaluates to a symbol. So quote the ID, that's a symbol. This is a symbol literal for this back to set symbol is a symbol. This is a symbol. The hash mark is a symbol. Here's a hash mark that has a backtick in it, and in order to write that, you have to put these quotation marks, single quotes. And here, a node parent edge quote ID. So this is actually like compiling a list of symbols. And then here, when we do BR, this also compiles a list of symbols. So the interpreter, these are the quotations, right? So the corresponding code in, if I move this down to the low-level virtual machine B4, these would have to what would they do? This whole thing would be converted to B4 code, okay? And like at the start, it's going to return a quotation. So at the start, it has to invoke the B4 compiler, which does not exist yet. So this is not. I mean, how do I say this? Like in B4, before I here. So this is before interpreter. You switch back and forth between compiling and executing on every line. So on every line, you're in execution mode. But you have this little colon here, and that puts you into the assembler for this line. And then it remembers what this is. But what we're talking about here is something where the code itself, based on the arguments you're giving it, are going to compile new code. And so this is beyond the assembler. This is a fourth interpreter. And so if I want to do it that way, I have two choices. One is to write the fourth interpreter, which is something I plan to do. You know, you got to say this is, you know, you got to go from assembly language, which is static. You know, I mean, this isn't completely static because you have some state here. You have the stack here at the time, but you can't. Well, you need the ability to switch the compiler on and off, right? Which is, I mean, this is not a lot of code. It's just. Or the other option is the device itself would just add these anonymous functions, these quotations, to the virtual machine's memory. And so it could invoke the assembler from JavaScript. So I could port this to JavaScript, and then when I do this step right here where I'm doing these quotations, I would just invoke the assembler, and you know, I would build a string and then pass that string to the B4 assembler, and then it would put stuff in memory. So I would do so I could do this quote ID myself, and then I would probably save this as like an li instruction to load an integer, and then whatever they, you know, so instead of the quote, I would just have the integer itself. I would just use integers rather than symbols. And then here it would be LB apostrophe O to load the capital O. And then set symbol. All right, so we need set symbol. Set symbol would be a function that is also in the interpreter. So we need so we need set symbol. How about set sim RT? Capital S maybe. Yes. Set symbol. Probably O takes an object and a symbol, or maybe a symbol and an object and symbol, and returns a modified object. Would be set symbol. We need invert. So this would just put another quoted ID into the thing. If the question is whether I would need a node, or I would need to reference the node and get its parent edges and that kind of thing. From the instruction set here, if I want to write this function in V4, but if I only want to write it as a hardware thing and just have this be apostrophe S whatever, which is what it says here so far, then in that case, then I don't need to do this, because the JavaScript code will compile this one. You know, this JavaScript would do this. Would it do it? Yeah, JavaScript would do this. And this would just be it would just compile a load li event, load integer. And then here invert would be a function call, and so we need to have an invert. we can do I. Yeah. So the numbers above here, these are arguments to the. Sorry, down here, these are arguments to the n command, and then but the commands themselves are n are node, replace, simplify, set symbol, invert. Sorry, invert. And then there's do, which is not really part of this thing. Do would be, do is, it takes an address and runs that address. So run a quotation, and that would just be just that. So you take an address that's on the data stack and you push it to the control stack, and then when you return, rather than going back to where you would have returned from, you now go back to this address. So it's like a jump, a computed jump. So do is how you invoke a quotation. So that word is pure B4. I'm going to save this. Is this making sense to anybody? I see people are watching. So all this other stuff probably will be part of the virtual machine. I mean, the graph drawing device anyway. The is-vex constant, the is inverted, all that stuff. But I think this is all implemented. I think all those things are implemented in JavaScript except for these. So it's just this. Okay, so let's see what else we have on here. See, I should have called these. Ops, right? I should. There's not much to this class, right? The class of objects. We have add shape, like a private thing, right? Oh, it's like building. That didn't work. I'll call it drawing, actually. Or scene building. Scene. Branch high-low. This is an operation. Or command, maybe. Why doesn't that work? Okay. So this is accessing dupe is an op. I is an op that pushes. That's this. That's yeah, what I'm calling II here. That pushes that onto that. Okay, I need dupe. So dupe is not one of these. This is load byte D dx. So that would be all of these are the same kind of thing. So we're going to load a byte, and we're going to, I think it's capital X bx. That symbol. Place, we're going to load a byte, and it's R bx. Simp is going to be load a byte, and it's lowercase s bx. Do is what I just said right here. Do that kind of separate, because that's not really, that's a generic B4 thing. Dupe is where we're at here, so I just did that. And branch so just the high and low. Where's high and low? Those must be in the RPN interpreter. Yeah, high and low. Yeah, no, here's I did identify them as ops. So based on the thing that we've, weird way to write it. I think it's based on the last. It's weird that I have a high. Okay, so when I create a branch, then it assigns high and low. So maybe high and low would just be I think that's it. Oh, okay, so yeah, I missed that here. RW is replace simp do replace simp when you invert. Maybe V, maybe I, tilde. Okay. I did say I for n. I try to keep these kind of like mnemonics, even though they're one character. Like, if this is the interface we have. Oh shoot! On that. Hopefully this does nothing, right? It should run and give me okay. So I got something. I didn't actually see where it went, but oh, because it's calling this bx return, bx everywhere. And so now that it's doing that, that's everything is screwing up. So this should be that. This should be this. When you're on the line by itself without a colon, you can put you can just push this directly onto the stack. But when you have the colon in front of it, you have to say what you want to do with this. Otherwise, this by itself will just compile that byte, but then that's not valid byte code unless you put the LB in front of it, or you put something in front of it that tells you how to interpret. Or actually, this would be one of the assignments, one of the things that modifies the O register. You don't want. Yeah, and here BX needs to have an RT in front of it, or else that's what's called. It's actually running the II, causing probably infinite loop here. Yeah, of course. So that's why I see it. That's why it's repeating over and over again, because it's saying BX and there wasn't a return here, so it's going all the way here and then doing something with BX and then returning. So it's putting ln on the stack. So yeah, see, See these alternating, the L and the N. Yeah, so now if I run this, I think it's fine. Ooh, no, it's not. Oh, I see. So it because there's no BR, it's all of these are the things that got pushed onto the stack that the BX didn't handle. There's no BX. Okay. What have I done here? So I've written this little shell that does nothing. So now I have a B4 script that is meant to control a BX device, and I have a list of the things that BX is supposed to do. I have a spec for what this is, which I've extracted from the Smalltalk version. And now I'm still at this point now. So what I could do there's two ways to do this, and the question is like, or there's obviously many ways to do this, but the thought is, I could implement B4 on Smalltalk, which is something I want to do anyway, and try and run this code, and then I would be able to implement this BX device easily by mapping to the things that already exist, right? At the cost of taking the time to implement the B4 in Smalltalk. But if I did that, then I could rewrite this and just bypass the high level code completely, and I would have a working system in Smalltalk that still did all this stuff. And so I wouldn't really gain anything, except now I would have verified that the B4 code is correct, right? And then I would have refactored the Smalltalk code to the point that it is a B4 virtual hardware device, and then I would be able to port that code. I would only have to port that Smalltalk device over, and then I could look at the two and see where it was going wrong. I guess what I'm saying is like there's a possibility that there's a bug in this code, or even though like it was a fairly mechanical translation. I'm only dealing with 3 lines of code. Like, could be that I've done something wrong here, and so that if I just took this, moved this to the JavaScript virtual machine, tried to run it, obviously it's going to fail. I mean, it's going to do the same. It's going to put these numbers on the stack just like it did here. Um, Either way, I need to write this device in JavaScript. Right? The only question is whether I also want to port B4 to Smalltalk. I know I do at some point, but it doesn't need to be today. Yeah, I think what I do is I'm going to take this. I'm going to write it in JavaScript. I'm going to take the B4 virtual machine that I have right now in JavaScript. I'm going to run this code on it. Probably make a nice little interface where I can run multiple lines. Run this on it, and get it to run this code right here. And hopefully have it draw that picture. And so to make it draw that picture, I need to implement these commands. And that will be a straight port of each one of these words over to JavaScript, from Smalltalk to JavaScript. And what it will do is it'll be a big, complicated JavaScript blob thing that controls the canvas. And instead of using my drawing tools, it'll draw on a what do you call it? Like just draw it on an SVG canvas. But otherwise, the logic is the same. The sizing logic is the same. I'd have to figure out how to do the how to port over the arrowhead logic. I think that's slightly different. But I think arrowheads are just a property of the line. SVG line or path arrowheads. It's not called head. It's called like markers or something. Marker, yeah. Marker. Yeah, marker end. All right, so that's an attribute that I can change at runtime. So this should be easy. Line, polyline, and polygon all that. So the only thing I think I'm missing that I kind of got for free from the Smalltalk stuff is the I guess it would be linear algebra that says I've got a line and I want you to touch like this particular point on the the thing you're pointing at. I don't think I implemented that myself. Let's see, that would be in GS graph. Ooh. No, I would want GS edge shape. So rebuild shape. Nearest position bound. Yeah, so I got that for free. And I would need to be able to find nearest position. But the nearest position on the bounds of the geometry. Which I mean I got it for free, but I can look at this, right? Like, see how it works. It's just some geometry calculation. But I'd have to say truncate this line at the edge of this circle, or truncate this line at the edge of this, wherever it intersects this. Which is not a big deal. I don't know it off the top of my head, but it just, I mean, you could draw the line to the center and then truncate. I don't know. I'd have to think about it. Like ideally, like you would draw a line to the center of a circle, and then from the circle, you would say, okay, well, just subtract the radius from the distance. This is not hard. It's not hard. It's not something I'm going to pose on the top of my head. I can write it down. But yeah, and that's it. So I need to port the I think now the RPN interpreter. Let's go back. So here, the RPN interpreter is all just Forthy stuff. There's nothing magic here. This is like its own interpreter. So like all this stuff, I think is I can ignore this. Maybe I need high, low, and things like that. But I think those should be part of the scene base. So for the most part, scene base is the virtual hardware device I want, which is what it should be like. So ideally, our RPN interpreter would be a generic thing that has nothing to do with Bex, and it would be the empty fourth interpreter. And so anything that is Bex specific ought to be moved to the scene graph. Or I guess maybe split this into two, a parent and child class. So the child class would add methods, because I think the idea was that that when it executes a token, it checks to see whether or not self-perform a token. Yeah. So if it's so basically if it's not if it's the tokens is an array of Smalltalk objects here, and if it's a number, we just or it's an array or it's a symbol, and we just push that onto the data stack. It starts with one of these, then we're going to treat it as a set of so we have a set of definitions, and we can just that's our assign and fetch and set or set and get. And otherwise, it's a this is also something I added on. And then if it's if it's anything else, then we say, is it in the does the defs dictionary contain that token? If so, then we're going to look at that definition and see what to do. It's either ordered collection or array. So, all right. So if it's in the definition and it's an array or an ordered collection, then we're going to execute it by stepping through those tokens. And if it's not, and right, so that allows us to generate a quotation on the fly as well. And then if it's absent, then we're going to perform symbol. So if it's a symbol and it's not in, or a token is a symbol, but if it's not in the defs, if it's not a key in the defs dictionary, then we send it to ourselves to perform it. And so this is like a Smalltalk way to execute that. So basically, the word dupe now becomes this. It triggers this. The word end would trigger this. The word high would trigger this because of this. Right? So that the token high would say a self-perform high, and then that would trigger this method. I like that. And so all the ones that are called ops, browse here, ops. All of these things probably should be, yeah, like this is like a generic thing. In push and pop, for example, are primitive opcodes, and is a primitive opcode, but it doesn't. But it's like operating on integers. This is operating on these graph drawings. So all of these things, I think, with the exception of pop and push, maybe return. Yeah, return probably should be. So I think today I would call this. I would follow the B4 conventions and call this um, CD, move from control to data. Push would be the opposite, DC, and return would be RT. And then the rest of these, maybe tokes. That's not an op, that's an assignment. It's access. Yeah, so the rest of these should be Bex specific. I'm going to change this to ops. Maybe we'll call it Bex ops. Ops. Bex. Do. You could conceivably you could call that a ops drawing. I don't know. I is ops specs. I is also ops specs because it's lowercase I is it's meant to be the uppercase I. Low is a bex thing. O is a bex thing. Op is a real op, or is it virtual machine op? Place is a bex thing. Turn is a real op. Simp is a bex thing. Simplify. I guess that word means other things. Bex. 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 Miss 3. XOR this is. Okay, so if I did that right, now we have ops and we have push, pop, return. These are the only things that are actually part of the generic interpreter thing. Now I'll call this name this here. And then I made this view, so that's a little weird. I didn't. It's not fully fleshed out here, but I added this browse thing so you could see that. You know, if you look at the methods here, you can see they all have a. They always are either part of the instance or the class, and then you can categorize them in Smalltalk. So I made this view that does the category. It lets you browse by category. I think most Smalltalk browsers, traditional Smalltalk browsers, have this, but it was lost in the transition to Clamorous Toolkit. You can filter this list by looking at a particular category. But you have to type stuff to make that happen. Whereas here, you can just click on it. I like this. Okay. But it doesn't say Bex here. It should say ops-Bex. You have to go all the way back here to generate that. Yeah. Okay, so all these things are the ops that. I should compare that to my list in Decker here. How do I get them both on the same side? Decker this. All right, so we have. So and is and, branch is here. I is I is I, low is low, O is OO, replace is replace, simp is simp, XO is here, X0, X1, X2, X3. There should be an X3 and X4, but I never really use them. Again, I was saying that you can cram, you know, a full truth table for 5 input variables into 32-bit register, so it's likely that I'm going to want to be able to illustrate that at some point. Those 5 bits are called X0, X1, X2, X4. And that's probably all I want. So I'm good with this. I think I'm happy with this. And then for drawing, what did I miss? Loop, hide, ID, invert, move, position. So somewhere in here we have move. I didn't see that. All right, so move and position need to be in here. Move and position. Move EVX position. Invert. Hide. H was also high and low, right? We need like a capital H. Or capital H would be hide and lowercase would be high. Yeah. That symbol position. Okay. I think that's close to all of them. Now I build this. I flesh out this interface in JavaScript. I think I can do that interactively. Yeah, but that'll be a different screen. I've been at this for almost 3 hours 15 minutes. All right, so yeah, okay. This was helpful for me. I don't know if anyone will ever find any value in this thing because I know I was jumping back and forth, but I feel like a good session. My head is much clearer now. All right. Yeah. Thanks for watching.